Okay, so we just ended on this slide. Just keep in mind though that when I know that this is a little bit confusing, but if we're assuming that the null is true and you get an outcome that has a very, very low probability of occurring, then that's basically good evidence that's showing us that the null is not true because it would not have occurred most likely if the null were true. Okay, so that gives us evidence against the null. All right, so the null hypothesis states that the claim that we are seeking, it states the claim we are seeking evidence against. So sort of think of the null and alternative as evidence. So we're either looking evidence for the null or we're looking for evidence against the null. The probability that measures the strength of the evidence is called the p-value. So we're going to find the probability of our event occurring. That's going to be called our p-value. So we're going to compute a probability. We're assuming that the null is true. Okay, so the probability computed, assuming that the null is true, that the statistic would take a value as extreme or more extreme than the one actually observed is called the p-value of the test. Okay, so that seems a little bit confusing. Basically, all we're doing is we're finding a z-score. So we're going to assume that the null is true. That's going to be kind of like the mean. So it's going to be like the mean of our normal curve. We're going to find the z-score of our statistic, and that's going to actually tell us how far we are away from the null. Then when we find the probability of that statistic occurring or that z-value occurring, that's going to be called the p-value of the test. Okay, so we're going to be always going back to the normal curve. Like I said, think of it as the population proportion or the population mean as the center of your normal curve, and we're going to find the z-score of our sample statistic and see how far away that is from the null or population parameter or mean that we're looking at. Okay, so now what does that mean? What does a small p-value mean? So what a small p-value means, that means that the statistic that we got is really far away from the null hypothesis. Okay, when you get a large z-score, okay, when you get a large z-score, that means it's really far away from the null, that's going to produce a small p-value. So that's going to say that the probability of that occurring is not very likely. So a small p-value is evidence against the null. It's unlikely that the observed statistic is likely to have happened by chance alone, and we have evidence to reject the null. So that's basically like saying, think about your normal curve, assuming that the null is true, assuming that he makes 80% of the shots. If we get a probability that's really little, that means it's in the edge or the tails of our normal curve, which means that's not where most of the other values lie. It's really far away from most of the values. Since it's really far away from most of the values, it's unlikely to have happened by chance alone. Something that's going to happen by chance alone is going to be close to sort of the center of your normal curve. Okay, large p-values fail to give convincing evidence against the null. So that means that probably the null is true. This means that the null hypothesis is true and we get that observed statistic by chance alone. And what that means is basically, so if we're saying that the probability or he makes 80% of his free throws and we get a large p-value, that means that what we got is probably actually pretty close. If you're thinking about the normal curve and we're drawing it and the p-value is 0.8 is in the middle here, if we get a large p-value, that means it's somewhere around that proportion or that mean. Okay, and that's sort of like saying it's in the, if the true mean or proportion was 80%, that big part of the bell curve, it's going to be in that portion, so it's most likely to have happened by chance alone. Okay, so let's interpret some p-values. The p-value is the probability of getting a sample result at least as extreme as ours if the null were true. Okay, so it's the probability of getting our result given that the null were true. So given that the mean or the proportion was sort of the center of our curve. Okay, now from the simulation example, let's take a look at the conditional probability. All right, we're finding the probability that p hat is less than or equal to 0.64. Why less than or equal? Because we actually thought that his claim, okay, we thought that he didn't make 80% of of the shots, we thought that he made less than 80% of the shots. Given that that he actually made 80% of his shots based on that simulation was 3 out of 400 or 0.7%. So here's how you interpret the p-value. So if the null is true and the player makes 80% of his free throws, okay, so that's like saying, take a look at your normal curve. If the proportion really is 80% in the long run, then there's only a 0.75 or 0.75% chance or 0.0075 probability that the player would make 32 or fewer of the shots by chance alone. Okay, so let's just break this down. So we're assuming that the null is true. We state the probability that our statistic would occur, and then by chance alone. Okay, so that's a really small probability, so that means it's really far away from where it should be. So since it's really far away from where it should be, then it probably is evidence against the null. Okay, it should be close to the null, and since it's not, then he probably doesn't make 80% of his shots. Okay. All right, so trial of a p-value. Here's what I want you to understand with this is we never have proof for anything. Ever in statistics, there's never 100% proof. It's all about interpretation. So just remember, you're never proving the null or alternative hypothesis. You're only giving evidence for or against it. So just think of a jury trial. For a defendant to be brought to trial, there must be some sort of evidence that they're guilty. So it's the job of the jury to decide if the evidence is convincing, okay? That is basically to decide that there's no other possible explanations for how the crime is committed. There's never proof that they're guilty or innocent. They just have evidence whether or not they're guilty or innocent. Okay. When we do a significance test, what the sample statistic does is it provides evidence that the alternative hypothesis is true or not true. So basically our goal is to determine whether this is enough evidence. The p-value, the probability of the statistic occurring, okay, that is our evidence. If our p-value is small, then there is convincing evidence in favor of the alternative because we're basically ruling out chance as plausible explanation. It's not where it should be. It's far away from where the value should be if the null were actually true. Okay, so let's take a look at this example. So let's say Mike was testing a new 7-iron and his hypothesis was that the mean is equal to 15 and the mean is less than 15. Now notice that the mean is defined here. It's the true standard deviation of the distances Mike hits golf balls using the new 7-iron. Okay, so this is the standard deviation. That's why you want to make sure you define that. So based on 50 shots with the new 7-iron, the standard deviation was 10.9 yards. Okay, so a significance test using the sample data produced a p-value of 0.002. So I just want you to sort of get a picture of what this is. So assuming that the null is true, so we're assuming that we're looking at a standard normal curve. We're assuming that the mean is 15. Okay, it's the average, the standard deviation of the distances that Mike hits his golf balls with the new 7-iron. So he gets 10.9 as his sample. Okay, and what this is asking is this far enough away from the mean to say that, hey, wait a second, your null is not true, or is the probability of that, given that the standard deviation is really 15, is that likely to occur? Now, a significance test using the sample data produced a p-value of 0.002. So that's basically like saying, here's the probability of all the possibilities in this entire normal curve, but 10.9 only has a 0.002 probability of occurring, which is not very much, okay? 10.9 or less, that's not very high. So what does that tell us, okay? We want to interpret the p-value in context and then answer the question, what I was just asking, does it provide convincing evidence against the null? Okay, so let's interpret that p-value. So what does that mean? That p-value is really small. So given the standard deviation of its distances, so given, notice how we're talking it back to the null, okay, given that the null is true, the probability of getting a standard deviation of 10.9 or lower with the new club is only 0.002. So it's the probability of getting that statistic that extreme or more extreme, so in this case or lower since we're testing less than, with the new club is only 0.002. This is very rare and unlikely to have happened by chance alone. Okay, and that's if you take a look at this graph right here, so this is saying like this is actually really far away from where it should be. So since it is really far away from it should be, does that give us evidence against the mean? Okay, all right, so it does, okay, actually give us evidence against the mean. So yes, random chance is not necessarily a plausible explanation. So it should have been closer to 15. The probability, if the null were true, should have been higher. So there is sufficient evidence to reject the null. Okay, we never say accept the alternative, we always say reject or fail to reject the null. Okay, and in fact, to say that the standard deviation of the distances is probably less than 15. All right, so the final step in performing a significance test is to draw a conclusion about the competing claims that we're testing. So we make one of two decisions based on the strength of the evidence against the null or in favor of the alternative hypothesis. So you're going to be coming up with a conclusion, all right? And when you come up with your conclusion, you're either going to reject the null or fail to reject the null. You're never going to accept anything, all right? Because we don't ever say we have evidence towards one is true, but we never say that we accept it because we never have 100% proof that our alternative is true or even that our null is true. So what a fail to reject null means, it doesn't necessarily mean that the null is true. It just means we don't have any evidence against the null. So for that reason, we're never accepting the null, okay, or stating that the null is true. So we're just saying that we're failing to reject it. Okay, so basically, in a nutshell, our conclusion in a significance test comes down to if you have a small p-value, we're rejecting the null. We have evidence for the alternative, but remember, we're never saying we accept the alternative, whatever. If the p-value is large, we're failing to reject the null. That means we don't have convincing evidence for the alternative, but we're also not stating that the null is true because we don't know for sure. Okay, basically there's no rule for how small a p-value should be in order to reject the null. But what we do is we choose a significance level to compare the p-value as. We write it as alpha. It's the Greek letter alpha, and it's down here. So if the p-value is smaller than alpha, we say that the data is statistically significant at some specific level of alpha. In that case, we reject the null and conclude that there is convincing evidence in favor of the alternative. So basically what the alpha means, and I'll be explaining this later on, is you have your normal curve, okay, you have what your null is, what you believe your null to be true, okay, and then you basically say, okay, you choose a area under the curve. So let's say we choose alpha equals 5%. Okay, so if we're choosing alpha is 0.05%, that means 5% of the time I'm going to reject the null. So if the probability occurs 5% of the time or less, we're going to reject the null, okay, and have evidence for the alternative. Okay, so what does statistically significant actually mean? So significant in the statistical sense does not necessarily mean important. It just means not likely to have happened by chance alone. The significance level alpha makes not likely a little bit more exact. So it gives us like sort of a level to reject or fail to reject the null. So how do we choose a significance level? So how do we say, okay, if the probability is this amount or less, we are rejecting the null. So most of the times people will choose alpha as 0.05. So it's basically like we are giving evidence 5% of the time that we're going to reject the null. So we're requiring that the data give evidence against the null so strong that would happen less than 5% of the time if the null were actually true. If you choose alpha as 0.01, that means you're not rejecting the null very often. So we're insisting on really, really strong evidence against the null. This result is so strong that it would only happen 1 in every 100 times if the null were actually true. And that's like saying if it only was going to happen 1 in 100 times and it did happen, then that means that the null is most likely not true. All right, so what if an alpha level isn't given? How do I know which one to use? The most common are 10%, 5%, and 1%. However, the most common is the 5%. If you're unsure and it's not given, just use the 5% level. So if you decide that a p-value is significant in comparison to your alpha, make sure that you understand the word significant is specific to statistics. Don't use another word such as important. When readers of the AP exam read your test, they understand that they assume that you know what significant means in the statistical sense.